Hey everyone, good evening and welcome to episode 5 of the Explorer series, the essential guide to adopting serverless architectures and technologies. Today's speakers are Nisanka Seniviratna, our very own senior software engineer at Capstars, and Sanjeeva Alves, who is a director of SRE and cloud at Pearson. So before we jump into today's session, I'd like to give you guys a quick introduction to our speakers. First up, Nisanka. So Nisanka is an innovator with extensive experience in conceptualizing, idea pitching, and evangelizing with a great product sense. His expertise lies in Java, Node.js, and Spring, and he is currently helping to build the payments infrastructure for Web 3.0. Interesting fact about him, he is also the Microsoft Imagine Cup 2019 European finalist, the Microsoft Imagine Cup 2018 National and Southeast Asia champion, and Asia Pacific finalist. So that's a little quick fun fact about Nisanka. Nisanka, thanks so much for being here with us today. Next up, we have our external speaker, Sanjeeva, who has so graciously agreed to share his expertise with us today. So Sanjeeva is a leader in digital transformation, software engineering, and IT infrastructure manager and operations. He is a social media expert, a DevOps practitioner, and a technological evangelist, with a focus in managing various IT and engineering teams in dynamic, mission-critical, and global environments. Interesting fact about Sanjeeva, he is the first AWS certified solution architect in Sri Lanka. Sanjeeva, thanks so much for being here with us today. It's an honor to have both of you on the panel. And without further ado, I'd be happy to kick the session off. So we'll be starting with Sanjeeva's session, which is going to be focusing on a high-level architectural perspective. Sanjeeva will be taking you through the future of serverless as a mainstream technology, how you make the architectural decision of getting into serverless, as well as when it's worthwhile and when it's not. Sanjeeva, take it away. The floor is yours.
Thank you very much. Thank you, Zara. And first of all, I'd like to be very grateful to Gapstar team. They have been doing a fantastic job over the years now, trying to bring various experts from the industry and creating a platform to share the knowledge across the board, which is something very much essential for our industry as a whole. So I think this is a great event, and not many of our organizations are actually investing time and efforts into these type of activities, but still so we have to appreciate what Gapstar has been doing. So today we'll be talking about serverless, and I'm not going to spend a lot of time chit-chatting. We can go into the discussion. But one thing that I want to highlight is I know this audience looks, based on the feedback that I'm getting, also the audience is a little bit of a wider group where we have few university students also, and also the industry experts who have been in the industry for a while. So what we thought of doing is to have this session starting from the basics and moving towards much more deeper technical hands-on activities at the later stage. So with a highly skilled engineer, we have Nisanka, so he will be also going through the technical demo type of details. So I'll be starting at a very high level overview of it. So let me pull up my screen for you. Right. So so in this overall session, we'll be discussing mainly on making the architectural decisions on serverless and how that would be. So I have been introduced. I'm currently working as a director at Pearson. So I don't think we need to spend any much more time on that one. So let's get into the meat of the presentation, where I kind of wanted to explain you about what serverless is basically. So serverless architecture is largely based on functions as a service. Nowadays, you have been hearing, this AAS, as a service models everywhere. So this is another type of a, as a service model, which actually the function as a service. In some cases, some people call it as a CAS as well, compute as a service. So, but basically this allows cloud platforms to execute code without need of a fully provisioned infrastructure instances. So that is basically the idea of this whole thing. So this serverless model is mostly stateless and server-side functions that are basically event-driven. So the one key element that we need to think about there is that event-driven nature of this. So any applications that we are developing or architecting on top with the serverless, we have to look at that aspect as well on an event-driven architecture. So this is fully managed by the cloud providers. Now, if you look at this diagram, you can see on the left side there we have different models. So one model is the dedicated server model, which we have been using traditionally, where we have a dedicated server. Buyer has a dedicated server or a network infrastructure for our applications to run. And provider's responsibility is, if you go down in a dedicated model, if you can see down, you can see the provider will provide only the network and network infrastructure and basically in the service, basically the server. So in a dedicated model where we get the entire fresh server and we have to manage the operating system, applications, functions, services on top of it, which is the dedicated model. Now this has evolved over years and it became to a more of a IaaS model with the infrastructure as a code being introduced, and the infrastructure provisioning and the underlying infrastructure is fully managed by the cloud provider. And we have to only manage the operating system, applications, and functions. This is another way of doing. So in this diagram, the provider is the cloud provider or the data center provider. In Sri Lanka, we don't see data center providers as such, apart from very few, apart from two major telecom entities. There are many data center providers, but in largely globally, there are data center providers as well. They are not just the cloud providers, but they provide data centers, dedicated data centers type of data center providers also there. So so provider means here is the cloud provider, or the provider, or the person who we are buying the service. And the responsibility between this buyer and provider, that means us and the infrastructure provider, is highlighted in this diagram. Now in a PaaS model, if you are familiar with EKS is an example of PaaS, where underlying network infrastructure, servers, and even up to the operating level, the EKS is managing. We don't see the underlying servers of EKS. We don't need to manage the underlying OS operating system of that. We have to manage the application, function, and service. Now, serverless takes us one step further. Serverless even takes us to a situation where we only have to manage the function. And the underlying middleware part of it. For example, if you are running a Java code, you need to have WebLogic or JBoss or whatever the middleware to run it. But in this model, with serverless model, we are eliminating that underlying runtime environments also. We are pretty much giving that responsibility to the cloud provider. So this is kind of the evolution of serverless model and how serverless operates. So with that, I wanted to give you few quick examples of serverless, because this session kind of starts from kind of basic level. Some of you might be already familiar with these ideas, but it's just worth to refresh, because then when we discuss these basic ideas only, we can build the more advanced topics at the later during this session. So AWS Lambda, Microsoft Azure functions, and Google Cloud functions, and IBM also has I think OpenWhisks or something. Yes, OpenWhisks. So are kind of well-known serverless services that we can purchase. So mainly the convenience and the cost saving associated with this on-demand auto-scaling environments is the driving factor of adoption of this serverless model, because rapidly the serverless model is being adapted, and many, in fact, non-technical people, especially some business non-technical people, thinking that this doesn't involve servers. That is not true. This is involving servers, but it's just that we are not managing the servers. So for us as a buyer, as a consumer, as a software developer, we really don't care what the server is. But actually, the servers are there. So that misnomer also I kind of wanted to clarify. So next, I think need to understand a little bit about serverless computing benefits. That is because why I want to cover this aspect as well is, as an architect, when you take decisions, you have to you should know what are your strengths in a specific technology and what are your weaknesses in a specific technology. So if you are thinking like an architect, going to become an architect, then you need to know constructively the good things and the bad things of a certain technology. So we have to critically analyze as good architects what are the good elements of this serverless and what are the things that we have to kind of eliminate. So because why I said that is, architects, modern day architects, we all are very passionate about technologies. We spend hours, sitting on the sitting in front of the laptop and trying to learn a new technology and trying to master a super cool technology. So as soon as we learn that technology, we all feel very empowered about that technology, and we try to implement that knowledge that we have to all the solutions, all the problems that come across, which is not a good way of becoming an architect. It's like, there's a saying, person who holds a hammer sees the entire world as a nail. So we kind of don't want to get into that situation where because we, as that is natural to highly skilled technical people, because when they learn a technology, they get so passionate about it, and then they kind of forget about the disadvantages, just get only the benefits and trying to apply it. But it is not that. As architects, we have to always look at the business element of it. So without spending a lot of time on this one, I want to cover this serverless computing benefits here. So the first one is transparent costs. As I explained, it is something where you only have to pay for the execution. So cloud provider charge you on a per invocation basis. That means if there has to be some sort of a triggering point, a user click or an API call or whatever it is, when that cloud function is triggered on serverless environment, then our code will get executed and it will do the job and it will sleep back again. So it only charges for you to the time that this process was up and running. So that is kind of a cost beneficial for especially applications that are event driven. But if there are applications that are long running, that requires long running application, then this model using as it is may not be helpful. There are ways to get there, but still that is something where we have to think about. And then the next element is the productivity boost. So productivity boost is something where we can achieve through this, because engineers who use serverless can simply deploy their code without having to manage any servers. I mean, you don't need to have an army of SREs or army of systems engineers to manage the entire fleet of your servers and manage the have separate observability tools. There is very, very less. The as soon as you wrote the code, it is very few simple steps to get it to the production. So you don't have to manage servers, and that increase productivity a lot, and also that helps to faster time to market, which is another benefit, because In traditional model, if we had to buy servers and if we have to manage everything from our own and then deploy an application on top of it, it will take ages. And also, this is auto-scalable. Being able to scale as workload change means developers do not have to worry about the capacity. So cloud infrastructure allows for rapid deployments of added resources. So it also kind of releases resources when they are no longer needed. So during high traffic times, end users do not experience delay in response time because the technology automatically adjusts. So that is another benefit of this this thing. So I think, and one other thing that I want to highlight is this is kind of a polyglot environment. That means you can build one large application from many different languages. You don't have to have this entire stack, either Java stack or a .NET stack. You kind of don't need to limit this. You can use different codes for different functions, different business elements, and you can build it in a way that works together. So that is kind of very good way. I mean, then we can get the maximum out of this languages. Some languages are powerful for some activities. So we can use those language for that activity and put it on a serverless environment. And then we can use another language which is powerful for another job. And then we can integrate both this into one application through API. So, whatever means. So that is something where another thing that I wanted to highlight. So very quickly going, what can go wrong with serverless? So one thing is that I mean the number one problem is companies believe that serverless is kind of either it's all or nothing. No, it's wrong. We can systematically look at an application and move some parts of that application into a serverless environment where the other parts can be kept on a cloud environment or on-premises environment or a Docker Kubernetes type of environment, which we can do. But we can have. It is very possible to manage and run a hybrid and multi-cloud infrastructure with this serverless. So usually, when someone is trying to move to the serverless, the biggest fear the architects would bring in is because they think about the broad picture where they want to do the entire thing for serverless. It's not like that. Because in application, we have legacy applications. Some of the big legacy monolithic applications are really difficult to move to a cloud. Now, for example, if you have an old ERP system you have been using for about 10 to 20 years, then these are non-cloud applications, these non-cloud native applications. So these applications are not built to take the advantage of this auto-scaling capabilities of cloud. So this is one thing where we need to look at it. Now, when you are designing a serverless architecture, if you are making sure one part of your product is running on serverless architecture and putting the output which cannot be handled by the legacy part of the application, then it creates a huge issue. So that is one element you need to consider when you are deciding an architecture. Whether the speed of the serverless components that gives to the entire application suite will be okay, or to the legacy parts of it. So that is something where you need to think when you are running a big application. So which is the same thing again when it comes to latency. So for example, if related to the previous thing which I said, the applications do not run continuously in a serverless environment. Instead, they are powered down between requests. So when a request is received, the provider activates the resources and responds. Provider invokes the function and responds when a trigger happens in a serverless environment. So this is what happens is basically spinning up this dormant code and executes it. So it takes time. So if you are deciding an application for, let's say, a stocks exchange, sometimes serverless may not be the best solution. because it might require microseconds of time sometimes. So there is some sort of a latency in evoking this function. So that is also some element we need to look into, take into consideration when we are designing an architecture on a serverless. And the other one is security and privacy. Everybody still in modern era has some sort of a fear on security and privacy. But again, it depends on the country rules as well. In some cases, some of the applications, some countries are bound to have that in their own soil. So because of that, they want to have it within the country. So they are not allowing them to move to cloud. There are all sort of privacy related, security related matters which can block us from moving towards this the serverless. So then the other element is what can go wrong with this serverless is choosing this platform early. So because different technologies and different cloud platforms are specialized in different areas, and some AWS has some strengths and Azure has some strengths. Now, for example, Microsoft Azure works really well with their companion product suites like .NET and their entire suite of companion products. Microsoft Azure works really on the Google Cloud wise. If an implementation requires interfacing with multiple systems, Google Cloud has numerous APIs to simplify integration. So Google Cloud is more stronger than in that area. So choosing a cloud platform is also very important to build in a way to avoid the vendor lock. Otherwise, we will have to locked into a one vendor cloud vendor. And another one very quickly I want to tell you is, for serverless is cheaper, but it is not always cheaper. If you are having unpredictable workloads, then probably this is good. But if you have like a requirement of continuously running things, again that might be different. So with that, without taking a lot of time, I want to move to the next one to talk about some sort of a cloud like serverless architecture use cases. What sort of applications where we can use serverless. Because Sarah, I believe I have like 5 more minutes.
Yep, correct.
Okay, cool. So then I'll try to cover this aspect as well, and probably we'll have some questions in between. I know some of you are in fuel queues and all that, and still attending to this session. So I'm really grateful that however what has it is, we have to continuously keep our quest on this technology. So this use cases now. Coming back to the topic. So serverless architecture, as I said before, it is best to use for a short-lived task and manage the workloads with a kind of infrequent, unpredictable traffic. But one thing that we previously mentioned also is this is like event-driven architecture. So if there's a trigger-based activities, this serverless is best. So if any user activity that triggers an event or a series of events is a good candidate for serverless architecture. Now, for example, a user signing up for a website may trigger a database change, or it can trigger a function to send an email. These type of things will trigger by an action. So in such a case, this serverless is very beneficial. If there is a element where you have to trigger something and do something and then get out of it, this is the best. And then in Amazon, you can build this API gateways with serverless functions and build. It can be used to build the RESTful APIs, and which will scale on demand. So building RESTful APIs is another use case where when you are architecting this. Architecting your application, you can think about using serverless in environments where you want to build RESTful APIs. And also there are some processing that happens like asynchronous processing. So serverless functions can handle behind the scene application tasks. For example, rendering product information or transcoding video after upload without interrupting the flow of application or adding any user facing latency, because it will sit behind, let's say if you upload a video into your application and video maybe is still playing, but you can trigger a separate function in a serverless environment to transcode that video into a different sizes for a different platforms to operate. That type of activities, the asynchronous processing can be done. Synchronous processing is difficult directly, but it is doable with another architectural aspects. And also this is good for security checks. Now, in modern day, if you are working on containers or especially in containers, now you have to always run security scans for containers or security scans for servers or automated pen tests executing. Those type of environment, those things where you can do security checks, you can run the functions. For example, functions can be evoked to scan an instance for misconfigurations or vulnerabilities in the container. Or functions can be used as a more secure option for SSL verification and two-factor authentication for a container or for application. So security checks is also something where we can use this. And also finally, which is something that I always talk about, the CI/CD pipelines. So serverless architecture can automate many of the stages in your CI/CD pipeline. For example, code commits can trigger a function to create a build, and then pull requests can trigger automated tests. So when you are designing your own CI/CD pipeline, the serverless architecture is essential. I mean, it gives a lot of clarity. So I have put some diagrams. I have taken this actually from internet. I want to mention that. So this is how serverless functions work. This is a basic view of it. It says, you upload a function code to a cloud provider account and then defines the triggering points. And then cloud provider runs your function when it triggers. This is kind of the basic view of it. It's all kind of aware. And this is kind of more of a user case situation where a user clicks a button or a link to get product data, and then it evokes a REST API call to an endpoint. And then that endpoint, there you run this cloud provider, execute the function code to retrieve the product data and returns that to the user. So the function runs and function gets the database details and it provides back. And then it dies. So, so when you are deciding a full architecture of this type of a serverless environment, where you have to look out how your databases has to be placed and what sizes of databases you have to have. I mean, how you can break down data in a more meaningful way without having the entire set into a one large database, and designing an architecture that helps this overall serverless architecture works. So that I think pretty much that is what I want to cover with this time. If we have questions, we can, I mean, Sarah will give us a time to discuss that in more detail. If there are more challenging advanced questions, we have Nisanka. So I'll let Sarah to take over.
Thanks, Sanjeeva. I'm sure that our audience learned quite a bit from your sessions. Thanks so much for sharing. We do actually have quite a number of questions that have come in. So I'll take maybe one of them now, and maybe we'll take the rest later so that we don't cut too much into Nisanka's time as well. So I will take one question, and this would be to you, Sanjeeva. And the question is, how much, I'm assuming this is in terms of the way serverless ties into the architecture, but how much does it scale up in terms of concurrency and requests per second?
It actually depends on the cloud provider nature, cloud provider, as well as your application as well. I mean, I don't have kind of a direct answer to that right now in my head, because it depends a lot, because we can define this architecture in a way that can achieve to a significant low latency levels. But again, it depends.
Right. Thanks, Sanjeeva, and thanks to the audience member who asked the question. We have another quick question that just came in from Shashika Chaturanga. And the question is, what is the advice you can give us to implement server application using Lambda? Actually, I feel that maybe Nisanka would be able to show you guys in the upcoming session. Yeah. All right. So Shashika, stay tuned. Let's jump into Nisanka's session now. So Nisanka, the floor is yours. Do continue to the audience, do continue to send us your questions through the Q&A box at the bottom. We have a live Q&A at the end of Nisanka's session as well. So stay tuned for that. Until then, Nisanka, over to you.
Thanks a lot, Zara. Thanks a lot, Sanjeeva, for that interesting presentation. Let me quickly share my screen. Hope you guys can see my screen, yeah? Zara, is my screen visible in your end?
Yep, all good.
Awesome. So my topic is serverless with AWS with a specific focus on Lambdas. So as it states here, I'm Nisanka Senivaratna, and I'm working on a company called OnRamper, which is developing an exciting platform helping to convert fiats into cryptos. So most of the people in Sri Lanka might be very interested in that. So if you are interested, just pick me up after the session. So I would like to consider myself as a Lambda mythbuster, because over the past 6 or 7 years, Lambda has come up a long way and the serverless journey has evolved a lot as well. And during this time, I've encountered people who share various opinions about Lambda and how it behaves. So during this session, what I'll try to do and my best is to talk about the myths, the solutions, and the problems that Lambda brings about. So the initial topics for the session today are the Lambda function structure, how the Lambda functions looks about, how the boilerplate looks about, the languages which are supported by Lambda. So this is also a very big misconception that's out there. The code duplication across Lambdas, because people consider Lambdas as very microservicey or very fine-grained functions, and they think, okay, the code will get duplicated around these because they are singular fine-grained functions. Then I'll talk about how to execute a Lambda from a synchronous perspective and from an asynchronous perspective as well, because a lot of people think in the synchronous perspective. I'll go into the synchronous perspective. Then the favorite topic of all, the cold starts. I saw several questions in the chat as well in this regard. And I'll try to do a simple demo if the time permits. So the Lambda function, this is how it basically looks like according to the screenshot. So the boilerplate Lambda function that you get has 3 components. The first component is a handler function. So handler function is what gets executed whenever you invoke a Lambda function from outside, from various services or through an API gateway. So the request initially comes into the handler function and it gets executed, and the logic in the handler function can call whatever other functions or methods that is in your program and execute as needed. Then you get 2 more important objects. The most important of it all is the event object. So this event object contains all the data that you receive from the trigger. So it contains all the request body, the request URL, the query parameters, path parameters, all the information, all the important information, I would say. Then there's another interesting object that is being provided called the context object. So this context object has some of the runtime information about the request IDs, the log info, the log group, etc. And in addition to these 2 objects, we can take use of a lot of other optional objects which are provided by AWS as well. So going into the runtime API and layers, this is a very favorite topic that I have. because it comes up with a very popular misconception about Lambdas that people have. So when you go into the Lambda introduction page, what it states is Lambda just supports Java, Go, PowerShell, Node.js, C#, Python, and Ruby. Then people automatically assumes those are the only languages which are being supported by Lambda. So for example, I have met people who loves Rust, but since Rust is not here, they think, okay, Lambda is out of the question. But this is actually not the case, because the Lambda team has identified this and they have provided something called a runtime API. So through this runtime API, you can code in basically any language which is being supported by the Unix infrastructure. So you can use hundreds or thousands of languages which is out there with Lambda through the runtime API. In addition to that, the second thing that I would like to talk about is about Lambda layers. So what is a Lambda layer? So in order to talk about a Lambda layer, we have to understand about some of the problems that some of the developers face when they are developing microservices and serverless, etc. So a serverless function, as I told earlier, it's a fine-grained function, right? So when you have a fine-grained functions across the organizations running, especially in an enterprise context, there will be duplicated code segments or functions, right? So then people think, okay, we can't share these across the Lambda functions. So people think that's a disadvantage and that will bring about maintainability issues going forward. But this is actually not the case. So AWS has provided a solution for us, and that solution is called layers. So if you want to reuse code or anything between Lambdas, you can simply place that code in a Lambda layer, and the Lambda functions can basically access them. But what you have to keep in mind is these Lambda layers have a five limit. So that's it. When it comes to the Lambda execution model, this is also a very interesting topic that I like to discuss. Most people come from a very synchronous perception of programming. I think it has probably to do with the way that the humans think, because what synchronous programming means is everything happens after a step, right? So you do something, you wait for the result, and that's it. So this is what you learned in the university years. This is what you learn from a flow diagram. If you drew a flow diagram or a sequence diagram, you drew a line to execute a function, and then you always do a line back to get the return. So this is the synchronous way of thinking. So because of that, people think, okay, we can only execute Lambdas in a synchronous way. So because of that, it tends to bring about some problems which are unnecessary into the Lambda domain. So I'll talk about that in the future slides. But actually, Lambda supports 3 ways of execution. So the first one is a synchronous approach, which everyone is familiar with. So there's an endpoint which is supported by API gateway, and through the API gateway, the request comes and hits the Lambda function. The Lambda function gets executed and does whatever that is necessary. But then there are 2 other interesting ones called the asynchronous execution model and the stream-based execution model as well. So asynchronous execution model is actually very cloud native, I would say. So what it does is, now in synchronous way, I would reiterate what happens is we hit an API endpoint, it calls the Lambda, waits for the result. When the Lambda returns, it returns the result back into the client. But in asynchronous, what happens is if you publish an event, let's say into an SNS, or if you put an object or update an object in Amazon S3 bucket, those services, the S3 bucket or the SNS, they will simply invoke the Lambda function. They won't wait till the Lambda function returns with the result, and they will simply exit. So this is a very interesting execution model which is out there in Lambdas, and you have to keep this in mind whenever you develop, because you can bring about a lot of efficiencies using this asynchronous execution model. And third up, you get the stream-based or the pull-based execution model. So if you get services like Kafka and Kinesis, which has stream indate or DynamoDB, you through the Lambda, you can always poll them and execute the function whenever there are changes. So you can do this with CloudWatch as well. Then the favorite topic of all, the cold starts. So I saw several different messages in the chat as well regarding cold starts. So before talking about the cold starts, I'll define what a cold start is so people have some contextual idea. So in order to identify the cold start or define it, we first have to understand how actually a Lambda gets executed in the environment. So what happens is not whenever, actually, when the very first call comes into AWS Lambda, it spins up an environment at that point. It does not have a pre-provisioned or pre-existing environment with an OS. It doesn't have that. So in EC2, you get that, but not in Lambdas. So whenever you get the very first request into the Lambdas, it creates an environment with the operating system and all the basic functionalities which are there. It spins up an environment. Then into that environment, they download whatever code that you have written, the functional code that you have written for the Lambda. They download that. So this takes some time, right? So this time is called the cold start time. So yeah, but the thing is how AWS works with, especially with Lambdas, is, well, for the very first call, you get the cold start time. Then that environment exists for a while. It doesn't die down after the request expires or the request returns the result. It doesn't die down. So instead of that, it exists for a non-deterministic amount of time. So you can't actually predict till what time it will exist. So during this time, if more calls or more requests come into Lambda, what will happen is they'll use that same spun up environment to serve all these requests. So then in that case, we won't have cold starts because the environment is already there. The code has been downloaded already there. So we won't have any issues. That's interesting, right? But after a certain period of inactivity, this environment, it will die down. AWS will automatically kill off that environment. So whenever a request comes afterwards, what will happen is they'll have to spin up a new environment and download the code, start putting up a new execution environment, etc. So yeah, this is the problem of cold starts. So actually, cold starts happen in two ways, if you think about it. The way which I mentioned right now, it's the first way and the way that most people know of, or the most commonly aware of there. But the second way is the one that we have to think about a lot, and one which has sort of implications in terms of production. So the second way a cold start can happen is, imagine you have one Lambda, which is servicing a lot of requests. And at some point, if it exceeds the number of requests which it can cater into, what AWS will have to do is they'll have to horizontally scale. So then they'll have to spin up another environment, copy all the code there, and have that environment running as well. So instead of just one environment, you'll have two environments. And when more calls coming in, you'll have to increase the number of environments. So whenever a new environment pops up, it will have to spend some time on a cold start. So this is the real issue, I would say. So the solutions that we can give into these two cold starts problems are vastly different. So during the next slide, I'll talk about it. So although cold starts are a very discussed problem in Lambdas, according to AWS research and even with my experience, the cold starts happen in about 0.2% of the time in production environment. It doesn't happen more than that. So, and a cold start, it doesn't take more than, I would say from my personal experience, it won't take more than 1 second. But I've heard for some people who hasn't developed proper architectures or who have very bloated functions, bloated Lambda functions, they have spent more time there for the cold starts. But usually if your function has been built properly, it shouldn't take more than 1 second, and usually it takes milliseconds only. So those are two interesting facts about cold starts. Then yeah, so for the first way of cold starts, which occurs due to the expiration or the killing off of a particular environment, the solution often suggested is a warmer. So I'll talk what a warmer is. What a warmer is basically it's a function which triggers the Lambda function periodically. So then what happens is when the Lambda function is triggered periodically, it doesn't die down. So it exists forever, basically. So this can be done using a CloudWatch event. A CloudWatch event is something like a cron job. So yeah, you can do that. But I've seen in certain architectures, they do this for all Lambda functions. But this is actually an anti-pattern. You only have to implement these CloudWatch events or warmers into synchronous functions. You don't have to implement these for asynchronous functions because just imagine in an asynchronous function without the client waiting, about 100 milliseconds or 200 milliseconds of delay won't actually matter. It will matter for an end user, for a client-facing side of the application, but not for asynchronous events. So that's something that people will have to keep in mind when developing. Yeah. Then, okay, the solution for the first way a cold start happens is the warmers, obviously. But the second way it happens, the cold start happens, I told it happens because of the high load. Then the application horizontally scales with more and more instances of lambdas. So to solve this second problem, there's a solution called provision concurrency. So this provision concurrency feature was implemented by by AWS quite recently. So most people aren't really aware of this. So I'll discuss about the provision concurrency in the next slides. Before talking about the provision concurrency, people have to have an idea about the patterns, the invocation patterns in Lambda, especially the synchronous invocation patterns in Lambda. Yeah, because I told the cold starts aren't that big of a problem when it comes to asynchronous, right? So we have to talk about the synchronous. So in synchronous, what happens is there are two ways of invocation. One is a simultaneous request, and other one is the request with a sort of a delay. So a simultaneous request is, just imagine 6 or 10 or 1,000 requests coming into the Lambda at the same time. Then what Lambda will do is they'll spin up an environment for each and every request if the requests hit the Lambda at the same time. So in this case, there will be a cold start for each and every environment. So this is a big issue, right? So this is an issue with the simultaneous request. The scenario B is if there's even a slightest delay with these requests coming into the Lambda and hitting them, then the cold starts will not be that of an issue because Lambda will manage that internally. So these are the two invocation patterns that's out there. So what are provision concurrencies? Now, previously I mentioned the second way that a cold start can happen is because of the horizontal scaling, right? So when horizontal scaling, basically what it means is creating copies of an environment and spinning up environments as required. So it takes a cold start. But what a provision concurrency means is we have a predefined set. We can supply AWS with a predefined set of environments with its own configurations. And these environments would be always up. They would be always up and they will be always warm. So in that case, we won't have to spend much time for the cold start. So they'll be always warm. So this is actually the best solution for the prod environments, which are often suffering with the cold starts. So yeah, I think this answers some of the questions which are in the Q&A box as well. Then I would go to some of the anti-patterns in Lambda, which I have observed over the years in coding. So the first one is people use Lambdas for very CPU intensive processors, which takes a lot of time. It's not that great for that, from my personal opinion. It's a subjective opinion actually, but from my personal opinion, it's not that great. Where Lambda has a towards strength is in IO intensive applications, which requires extremely high scalability. So yeah, that's where Lambda is, and that's where the Lambda strength lies. But if you want to run very long running processors, always opt for an EC2 instead of a Lambda. Because when the function is running 24/7, it doesn't bring about much benefits. The Lambdas doesn't bring about much benefits. Then the second one is always go for fine-grained microservices with Lambda. Do not implement very large microservices in Lambda. Never do that. It's an anti-pattern. It always takes about the cost and the maintainability benefits away from the Lambda. It's a guarantee. Next up, the second set of anti-patterns is Lambdas are by nature highly scalable, right? But the issue comes is when you use Lambdas with services which aren't scalable. So just imagine there's one programming component which can expand horizontally as much as it likes. and there's another programming component which this service calls, but just imagine it cannot expand with the load. Then there'll be a break, right? Then there'll be production issues. So do not use that. So if it's a must to use non-scalable services or non-scalable solutions along with Lambdas, always opt for something like an SQS. Then SQS can basically handle this difference between the vastly horizontally scaling and this highly scalable Lambda along with the non-scalable services. The thingy, next up, yeah, avoid synchronous architectural patterns. This is especially, you have to think about this, especially when it comes to long running processes or highly intensive, CPU intensive processes. I'll just give a practical example that I've encountered. So there was this friend of mine who was very into machine learning, and they wanted to upload a set of images into Lambda and to make the Lambda process those images, store those images in an S3 bucket, then get the process result from the Lambda, and then return the result back into the client. But this takes a lot of time, and it almost always exceeded the execution or the expiry time of the Lambda. So that's a very big anti-pattern. So instead, what you can do is change your mindset into an asynchronous mindset. And in that case, if I was the developer, what I would do is, instead of straight away going ahead, instead of straight away forwarding all those files into the Lambda, I would basically upload all those files into an S3 bucket, get the S3 bucket to trigger the Lambda, and do whatever that is necessary in image recognition or whatever, and then use another service, a notification service, to push those results back into the client's UI. That would basically be an asynchronous process, and it wouldn't hang up things. Useful tips, some of the tips that I added here, especially after having a look in the Q&A section. So yeah, avoid orchestration. So what orchestration means is people call Lambda functions within another Lambda function. So this, I think, personally introduces a lot of unnecessary complications and a lot of dependencies as well. And it causes very high coupling, which we should avoid at all costs. So instead of orchestration, always go with step functions. So what a step function does is basically decouples the calling between two functions. So that feature has been provided by Lambda. So use that instead of calling a Lambda function from the Lambda function. Then there's this concept called ephemeral storage. So what this means is it's a volatile storage. It's a nice word for volatile. So you all know what a volatile storage is, right? It basically gets lost, whatever data which is in the volatile storage, it gets lost after the execution stops. It's something like a RAM. So Lambda by default provides an ephemeral storage between 512 MB to 10,000 MB. Do not use this to permanently store data ever, because I've seen people who do that and they lose their data, and then they wonder what happens to that data. Like honestly, I've seen even in production systems this happen. So always use that to store temporary data if you want. But if you want to store any persistent data, let's say it's a file, then opt for S3, or then if it's just data, then you should go with the DB. Lambda's default execution timeout is 15 minutes, but if your process is running for 15 minutes, then I don't think it's ideal for Lambda personally. So just keep that in mind. And when in Lambda is highly configurable. So in configurations, just don't give the maximum time of 15 minutes for each and every function. Just observe the usual duration it takes to run a function, and according to that stat, just leave a number there. You can observe this using various metrics provided by CloudWatch as well. Then the next point was to facilitate a point which was in the Q&A. So Lambda actually supports up to 1,000 concurrent requests, and at burst, it supports up to 3,000 concurrent requests. So what will happen after this is, whatever request which comes after this will get throttled, right? So it will get throttled and Lambda will scale up by 500 requests per minute. And then it will reduce the throttling. So this can be an issue for high available systems, because when throttling, basically it cancels out certain requests. So in that case, again, you can go back to provisional concurrency. So with provisional concurrency, you can scale up without this throttling problem, and you can avoid most of the concurrent request limits as well. So these are the useful tips. Okay, I have, how many minutes do I have, Zara?
How much longer do you need? You actually have
2 minutes.
Sorry?
Can I have 2 minutes?
Yeah, sure. Go for it.
Okay, then I would share my next screen. Hope you all can see my AWS Lambda console. So I was going to do some exciting stuff here, but let's see what we can do within the limited time. So I'll just show you guys how to create a Lambda function. You can log into your AWS console. Let's have it in Oregon. Okay, go to create function. They have tried various options. For now, I'll go with user blueprint because that's pretty much easy. Select this, select a blueprint. You can configure it as you want. Provide a name, demo. Then there are, like, various execution rows, security policies. These are very fine-tuned details. I don't think I'll need to go there. And it shows the basic Lambda code here. You can create the function. All right. So I have the Lambda function now. I'll do something exciting here. Deploy. All right. So I deploy my Lambda function. Let me add a trigger real quick. Let's go with a new API. Open. Awesome. So there's this API endpoint which has been given by Lambda to me. And yeah, here we have the solution. So I'll just go into the code and explain to you what happened. So if you go into the code, I'll just explain about the gravity of things that I did. So I created a Lambda function with the Lambda handler, and I'm returning this HTML file which I pre-built. So what happens is when I click on this deploy, and yeah, when I click on this deploy, and when I add an API gateway, and after I added the API gateway, I got this URL, right? So what happens is when I call this URL, as I mentioned earlier, Lambda spins up an environment, downloads the code, execute it, and returns you the result, all within 2 minutes. So I didn't take more than 2 minutes to develop this code and deploy it. So that's where the real advantage of Lambda lies, and that's where it brings all the possibilities, the interesting possibilities. In the golden ages, like when I started back programming, I just had to code things. I had to create a new instance in whatever the server providers, upload the code, download it there using Git, and run it, expose using different ports, etc. And it was a hassle. But right now, I don't have to face anything like that. Then the next interesting part is, yeah, I'll just drop this code into the chat. So, give me a second. Check. Zara, would you be able to forward this particular link to the users?
Yep, sure thing.
So this is where things actually get very interesting, I would say. Mind you, this contains this particular iframe. This is loading from a different site, so it will take some time for that site to load. But yeah, so Zara has dropped a link into the chat. I encourage everyone to go into this link and to use all your force and to try to take down this site. Yeah, with all your might. Just reload the site because this contains a lot of objects, right? So just try to reload it as much as you guys can. So let's take a minute for that. I can see whether you guys are really doing that or not, because I have this management console provided by Lambda. So this is actually a very interesting part. So previously we had to use this Elasticsearch, Grafana, etc., to aggregate logs from our server and visualize them, etc. But with these CloudWatch tools, which is being provided by AWS, we don't have to worry about anything. They just provide it. So the only issue is sometimes it takes a few minutes for the data to appear here, but yeah, I don't think you guys are able to take the site down with the number of requests. If there's any hacker, just don't try to hack it because it's an open link, but yeah. So that is pretty much it. So as you guys can see, this visualizes whatever the duration which was spent for a particular function. So as you all can see, it, even though that the function is very, the code which is returning the objects, they are very heavy. It only takes about 16 milliseconds on average to return the result. So yeah. So this is pretty much it from me. Yeah, over to you, Zara.
Thanks so much, Nisanka. That was a great session. We got some good feedback as well on both of your sessions today, both Nisanka and Sanjeeva. So moving on from that, there are quite a number of questions in the QA box that I see below. As Nisanka was saying, I think that a couple of the questions regarding cold starts were already answered. But let me just quickly open up the chat box and direct the questions to both Nisanka and Sanjeeva. And either one of you, depending on which one feels more relevant, you all can take the question on from there. So there are quite a number of questions. So to the audience, do stay patient. I'll try to get through each and every one of them. So the first question is it worth to implement highly available low latency systems in Lambda in terms of cost? Which is to say keeping control over hardware versus giving the control to the provider.
Probably I can take a stab at it and then Nisanka can add more. So the question is, suddenly it got disappeared. Okay, now I can see it again. Also, it is worth to highly. So the I mean, cost-wise, it depends, right? Now, for example, if you look at it, the high. So as an architect, when you are thinking about it, so you need to understand the availability metrics which you want to achieve. And it is, I mean, we all want everything at the same time. But usually that doesn't happen. So we kind of wanted to balance these things out. So cost is one element, and the high availability is another element. So there is, of course, when you have to achieve more on availability, the cost goes up. So you have to, so the comparison has to happen between the different serverless cloud providers, I would say, because you anyway you cannot negotiate on the highly availability. Like, once you define whether it is 99%, 999 or whatever it is, that first you have to define that. No? So once you define that only, you can go. And also the low latency aspect is also very important. So it again depends on what sort of a low latency that you can tolerate within your business transaction. So our question is pretty much where I don't have a direct answer, but I can give you the way that you can understand. You can come up with your own answer. So first of all, you have to define what is the availability number that you want to have, and the latency number that which you want to have. And then once you have those numbers only, you can go and check. Probably I would suggest Google has a better way of handling this situation as well. Because and also you also have put another thing saying keeping control over hardware versus giving the controller to the provider. Once you are on cloud, it is on cloud. It is with provider. So, unless you are looking for your data center own thing, there is not much of a difference between having it on a cloud server, EC2 instances versus for serverless, because the AWS has a better team, better automations, better way of handling the server related matters than us, most of us. I think I took a little bit more time in that one, but I can say if there's anything you can connect online through LinkedIn or anything like that, but it is high pointers that I wanted to cover.
Nisanka, anything to add to that?
No.
Cool. So thanks for the question. We're jumping on to the next one, and that is, how do you set up a provision concurrency?
I think that's sort of a very technical question. So there are enough documentation available out there with AWS. So yeah, I think you can follow that. It's an easy thing. I can if you want, I can just send you some links.
All right. The next one is another question. Could you give us some idea about cost versus scalability?
It's a very broad-ended question, I would say. So cost versus scalability. Okay. So the primary objective of a Lambda is, if you think about it, when you compare it with something like EC2, which is always available, is Lambdas by nature, whenever you don't use them, they die down, right? So you only pay for the computational time. So that's where the cost benefit really comes in. So you only pay for the computational time. So for example, let's say you have processors which runs only on very specific times, or you have users with who use the system in very spiked manners, right? In a very infrequent manners, or they use system in as a spike, right? So in that case, Lambda brings about a lot of benefits in terms of cost and in terms of scalability as well, because Lambda can horizontally scale as much as you want. So that benefit is there. But if the system is running 24/7 with the same predetermined or predeterministic load, then I don't see much of a point in having something like Lambda. You can easily go with EC2, right? So that's my take on it. Maybe Sanjeev has more points to add to that.
Yeah, I think the concurrency request per second is obviously you can find in these documents what is the concurrency and how much can handle per second. And but if you architect really well, you can go achieve things that are beyond what cloud provider also doing. In a way, it is depending on how you architect the system. But the one thing that we have to look at it is, I think, most of these architectural type of questions that are coming up with cost, I see I want to give one common question, one common answer, that is, when you want to decide cost, compare cost, before doing that, please try to find out what is your actual requirement. Without exploring the product, product or a Lambda services or any before going anywhere there for your application. If you are running a stock exchange, then you must be handling millions per second. If you are running shopping cart of Amazon, then again it's millions per second. It depends on you. So first of all, we have to think from within. Understand what is our limitation, what is our expectation, availability wise, what do we want, and scale up wise, what do you want. These metrics for our application first we have to define. Once that is defined, only we have to go and check what is better suited for us, because having a one EC2 instances will not give you redundancy, but one serverless function gives you redundancy. So it depends.
I hope that answered the question. The next one that we have is what if you do orchestration using an AWS event bridge?
That's again from my perspective, like you can do that, but again a very open-ended question, right? So it all depends upon the business case. So it depends upon the particular architectural decisions that you have to take. So you can either go with step functions or with bridges. Yeah.
Anything to add, Sanjeeva?
No, I think that is good. Yeah, again, these questions, best way is directly reach out and understand your scenario, and then we can give you, because you might be also wondering why we cannot give a direct answer, but we also want to know more about this whole thing. Then only it creates a picture, because we have certain 10 or 20 questions back at you when these type of questions come to us. Then we need to ask those questions and then get it clarified, and then only we can sometimes give you the direct answer.
All right. The next one, I believe that this question was actually asked during Sanjeeva's session. And the question is it suitable for enterprise apps? So I'm assuming it's the serverless adoption that you were talking about. Is it suitable for enterprise apps?
Is it, Sarah, you want me to do it, no?
Yes, I believe so.
Yes, okay. Enterprise apps. Not the entire apps, again, entire application, not the entire application. Some elements we might have to, run it in a traditional way in enterprise applications in some, but most of these enterprise applications are the ERPs. These type of applications are mostly event-driven type of application. So you can design on this. I don't see any issue, because traditionally there was a doubt over the years, like maybe 3-4 years back, there was a doubt whether serverless. Because people thought the serverless is just AWS giving their free space to people just to make money. That sort of a mindset was there in people. Where you run the servers and all that. Once everything is done, there's a spare compute CPU power which AWS can't do anything with it, so they are giving that to you to run your things. That was the initial mindset of serverless, but now we have came a long way from that.
All righty. The next one is actually quite an interesting question from Thani, and that is, can you explain taking the new QR Fuel app? What would be your suggestion? So I think I'll hand this over to both of you.
Good thing. I haven't thought about it. I think for me, I think it is good, because I think it is a good use case, because anyway it is triggered. No, it is triggered events. Everything is user invokes when you go into the fuel station and then present it to whoever it is. Then when they scan it, it triggers the event. So I think it is a good thing, unless I don't know whether the government will allow you to keep the data on a cloud environment. So either you have to have the database on-prem and the other things on cloud, which maybe makes things more complicated. But purely looking at an architecture point of view, I think it will be really good, especially cost-wise also, because we don't have enough money to bring fuel. So I don't think we will have enough money to buy servers. So cost-wise also, it is a good idea.
From my perspective, I think from what I got to know, they have already deployed this in AWS. And for the data also, they have an exception. Usually they want to store the data on-prem, right? Because of privacy or whatever concerns. But in this case, the data has been, let's say, sold to the highest bidder in exchange for the free software. But if you actually look at it, Lambda is a very good service there, because there are very spikes in the usage of the application, because in the initial phases of the application there will be spikes, and during certain times of the day there will be spikes in the usage, and during certain times, especially at night, the system won't be used much. So this is an ideal case for an EC2, I would say, from my perspective. Only thing you have to make sure is you shouldn't do too much of synchronous stuff along with it. So, and you shouldn't, depend upon non-scalable services, especially databases. You have to, consider scalable databases, or at least use things like SQS to manage the load. So, yeah.
Interesting question. Equally interesting answers, I believe, as well. In the interest of time, we're going to take perhaps another 2 to 3 questions more. There are quite a few that have been sent in. Perhaps following this session, we will probably look into sending you guys the answers, perhaps in a follow-up email or in a newsletter. But for the time being, I think we'll take about 2 more virtually. So the next question that we're going to take is, someone has said, there are, as far as they know, there are limits to Lambda. For example, the cluster supports only up to 1,000 concurrent requests. What to do if the limit exceeds?
I think I already answered that question in the last slide. So Lambda supports 1,000 concurrent requests, and at burst 3,000. So if that limit exceeds, Lambda scales up from for about 500 requests every minute by horizontal scaling. And during that time, it will throttle the requests which are coming in. So if you want to avoid the throttling there, then you should go with the provision concurrency. So yeah, that's a broad answer.
And the last question that we'll be taking is from Tihara. And the question is, what are the advantages Lambda and provision concurrency? What are the advantages of Lambda and provision concurrency versus something like ECS?
From my perspective, well, Lambda can bring out redundancies. It can basically bring about some features which aren't supported by native in using an ECS. So let's take again spikes in user demands, etc. If you have things like, it's also again an architectural decision, right? So it all depends upon the application. But let's say a normal application with regular users, with regular usage during all 24 hours, and let's say the application load is there for all 365 days, then maybe you could think about ECS. Otherwise, in other conditions, I would personally prefer serverless, but there are a lot of other considerations also you have to take into account. But yeah.
Exactly. Same as before. I mean, we need to know more to give a decision, because this again depend on the workload, the application nature, it all depends on it. I'd like to, because now the basic thing by theories wise, we can say, ECS you will have to have anyway. Cost wise, the Lambda has a benefit anyway, even you go with the provision. But up to what level? Provision concurrency, up to what level, that when it will go past the ECS, or should we actually consider it with EKs, not with ECS? So that may be another aspect. So again, need to know more about because when you're taking architecture, one thing that I want to tell you is from most of these questions, what I understand is all of us, even myself, sometimes we look at and try to compare two things only. It is very different. We need to understand the complete context of it. What the entire thing as a whole, we need to take a decision. That's how we take architectural decisions. Not only comparing only two things. We need to look at the entire thing. And then, compare and eliminate the other bad options and find the best option. So we have to answer questions for all the eliminating, because some combination, for example, there are workloads where it is beneficial for ECS, more beneficial in ECS, but there are more more use cases where it is beneficial for Lambda. So that again depends on the exact situation.
All right. Unfortunately, as you can see, the power has gone out here. But I do thank both of you for the session. I think that we all struggled with power cuts at different points today during today's webinar. But we persevered, and thank you everyone from the audience as well for joining into our session. I believe that maybe you would like to get in touch directly with our panelists as well. So I will just drop in their socials and their LinkedIns if you guys would like to follow them also. Do keep in touch with us as well. You can follow our GapStars LinkedIn page to stay updated on all the events that we will be posting as well. So I'll just drop them into the chat here. So do follow GapStars, do follow Sanjeeva and Nisanka as well if you have any questions or if there's any further communication that you would like to start with them. We will be getting in, the lights back. We will be getting in touch with you guys following this session as well. If you have any suggestions on topics that you would like to see in future episodes of the Explorer series, do get in touch with me, do get in touch with GapStars and tell us what you would like to hear. In the meantime, thank you everyone for joining in. Thanks, Nisanka. Thanks, Sanjeeva. And have a good evening, everyone. Thanks for joining.
Thank you.